This is Bob Capetta, and this lesson is on if-then truth tables. So P implies Q means if P is true, then Q must be true. So what does that look like? Let's construct our truth table. Here's P. Here's Q. True, true. True, false. False, true. False, false. If P is true, then Q is true. So how do you want to think about this? How do you want to think about this? If P happens, then Q must happen. And you will say false if you think that person is lying. Okay. So a way to think about this is if a person is standing in a parking lot in the rain, then that person will get wet. So I want you to envision two things. A person is standing in a parking lot in the rain. That's P. Q is that person's going to get wet. Maybe they have an umbrella. Maybe they have a raincoat, but at least their shoes are going to get wet. Something is going to get wet. So if a person is standing outside in the rain, they will get wet. Is that a true statement or a false statement? True, standing outside in the rain, true, getting wet. So yes, indeed, that is a true statement. The person is standing outside in the rain, but they didn't get wet. But you said if they're in the rain, they've got to get wet. Well, here's evidence to the contrary, right? They were standing in the rain, but they didn't get wet. That means that implication statement was false. They were not standing in the rain, but they got wet anyway. Well, that's okay. That doesn't mean the person was lying. You said if a person is standing outside in the rain, they'll get wet. Well, they weren't standing outside in the rain, but they got wet anyway. Maybe they got hit by a water balloon. So again, they might be telling the truth. They weren't standing outside in the rain. They didn't get wet. So, I mean, here's the idea. This is the key notion with an implication. If the first statement is true, but the second one happens to be false, the result is a false statement. TF leads to F. That is what our P implies Q statement is going to be. So whenever you see a TF, that's F on the implication. So let's go ahead and do another problem like that. Let's construct a truth table for the following. Let's look at not Q implies not F. Excuse me, not Q implies not P. Remember, our key idea was if the first one is true and the second one is false, that will yield what? That will yield a false. So we're going to make our table. So true, 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 false, false, true, false, false. I need a not Q. Well, if Q is true, not Q is false. If Q is false, not Q is true. If Q is true, not Q is false. If Q is false, not Q is true. And then I need a not P, because I want to look at it. Not Q implies not P. If not Q, then not P. If Q is not true, then P is not true. Let's take a look at that. What is not P? P was true, so not P is false. P was true, so not P is false. P was false, so not P is true. P was false, so not P is true. And we want to go with what? We want to go with not Q implies not P. Again, you're standing outside in the rain in the parking lot, then you will get wet. Is there evidence that that is a lie? If there's evidence of a lie, then you say that it's false. Not standing in the rain, not getting wet. That's not evidence that that was a lie, so that's a true statement. Standing in the rain but didn't get wet. You're a stinking liar. You weren't standing in the rain, but you got wet anyway. Maybe you got hit by a water balloon. You were standing in the rain and you got wet. Boom. Again, notice the TFF. But I want you to notice something else. Not Q implies not P is TFTT. What did we say on our previous page? Remember? P implies Q, TFTT. They are the same. They are equivalent statements. Not Q implies not P. Is equivalent to P implies Q, which is kind of interesting. So they are logically equivalent. If P is true, then Q is true is equivalent to saying, well, if Q didn't happen, then P didn't happen. Interesting way to think about that. Let's go ahead and build a truth table with 3 conditions, P, Q, and R. And this time our goal is going to be to construct a truth table for P or Q implies R. That's going to be our goal. And the key to remember on the implication, if you see TF, if the first statement is true but the second one doesn't happen, that means the implication is false. If P is true and the thing that follows it isn't, then the implication isn't true. Okay. So we have P, we have Q, and we have R. So true, 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 false, false, true, false, false. Double all these up. So true, true, there twice. True, false, there twice. False, true, there twice. False, false, there twice. And then go ahead and put in your horizontal lines. Okay, we're going to go ahead and construct our R column, alternating true, false. And these first 3 columns should always be the same when creating a truth table for P, Q, and R. Next, I want to look at P or Q. If one or the other or both are true, then that gets a true statement. One or the other or both, yes. 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 One or the other or both, no. One or the other, true, no. So you look for false, false, that's going to be a false in the world of P or Q. But I want to write R after it. I think it's worthwhile to write them in that order. Write the if statement first and the then statement after it. So it goes TF, TF alternating. And, you know, a common mistake students make is they miscopy the columns. So just be careful. Take your time on these. P or Q implies R. If P or Q is true, then R is true. We look for any TF. The first thing happened, but the second one didn't. That makes it false. TF gives us a false. First one happened, second one didn't. That gives us a false. First one happened, second one didn't. That one gives us a false. Any other TFs? Not that I see. So all of the others get trues. True, 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 true. And that is your P or Q implies R. P or Q implies R. Okay. Let's take a look at one more. Like that. How about P implies Q and not R? Let's talk a little bit about order of operations. P implies Q and not R. The implication always wins, so I want to go ahead and do it this way to make sure there's no ambiguity. So we'll do Q and not R first, and then say if P is true, then Q and not R has to be true. So I like parentheses to avoid ambiguity. You can take a look at your textbooks to look at the various orders. But again, the implication is always done first. So if I didn't write the parentheses there, I would have had to have done P implies Q first and then and, not R. So we're going to go ahead and make our chart, our PQR chart. TTTT, FFFF, TTFF, TTFF, and then it ends TF, 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 TF. And make sure you draw these so you can tell the difference between a T and an F. And you know I like to draw horizontal lines, so I will do that. So on Q and not R, so I'm going to recopy the Q column. Q column, TTFF, TTFF. The not R column, the not R column, R is T, so not R is F. F becomes T, T becomes F, F becomes T, T becomes F, F becomes T, T becomes F, F becomes T. Now I need Q and not R. Q and not R. Q and not R. Well, they're true if they're both true. And both, so I look for TTs. TT becomes T. TT becomes T. Any other TTs? Doesn't look like it. So all the rest of them are false. They have at least one false. So that's Q and not R, and I want to take a look at P implies Q and not R. So I'm going to recopy the P column first. P column, 4 T's, 4 F's. I like to recopy it. I want if on the left. I want the next one on the right. Q and not R on the right. So we've already done that. FT, Q and not R. F, T, F, F, F. I think that's a T. It looks like a T. T, F, F. So what do we know about implication? What is our issue? So I want P implies Q and not R. Is barely fitting this on my paper. Remember that TF, if the first statement is true and the second statement is false, if the first thing happened, it did, but the second one didn't, that yields an F. So where do I have TFs? Wherever I have TFs, that becomes an F. TF becomes an F. TF becomes an F. TF becomes an F. Any other TFs? I don't think so. If that's the case, all of the others then are true. And that is that if-then statement for 3. But let's finish up with going back to 2 for an if and only if discussion. So this time I want to take a look at these two things. I want to look at P implies Q. So if P, then Q, and Q implies P. Okay. We want to construct a truth table for that. And it's only got 4 elements in it. PQ, P, true, 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 false, false, true, false, false. Okay. So I can certainly do P implies Q. Next line, P implies Q. And if we're looking for if P is true, then Q is true, our little cheat code is you look for TFs. That yields an F. Where do I have TFs? I have one right here that yields an F. So all of the others are true. Now I want to do Q implies P. So I want Q on the left, and I want P on the right. Q is TF, TF. P is on the right, T, T, F, F. So if Q is true, then P is true. What do I look for? I look for TF. TF yields an F. TF is here, that yields an F. The first one was true, but the second thing didn't happen. Therefore, whoever made the statement was lying. The others are true. Okay. So I want to look at Q implies P, P implies Q. P implies Q from here, TF, TT. Q implies P. You don't really have to write it down again, but it's TTFT. You could just recognize that it is commutative. This one is. And what do we finish with? And. P implies Q and Q implies P. When is the and true? The and is true only when both are true. True here, false, false. When P and Q were both true, the result is true. When P and Q were both false, the result is true. So basically, P implies Q and Q implies P is the same thing as equivalent to P if and only if Q. Or the notation we looked at earlier, P with the arrow going both ways. If P is true, then Q is true. If Q is true, then P is true. That's what the if and only if statement tells us. And this is also known as an equivalence, using the word there as well. A slightly different meaning here. Notice, if P and Q are equivalent, the if and only if is true. P and Q both true, it's true. One's true, one's false, false. One's false, one's true, false. They're both false, therefore they're equivalent, they're true. So an if and only if statement is a sense and equivalence. And that will conclude this lesson.